Animal, vegetable or mineral, science or science fiction. Whatever else she may be, Miss Honeywell pulls in the crowds, even at a refined exhibition which only the top technicians can begin to comprehend. Honeywell's own spokesman says he himself doesn't know if this is electronic or mechanical or...
Hey everybody, welcome back. I've got another bit of old vintage test equipment here. From what I can tell, it looks to be some sort of generator, whether it's audio or RF, I'm really not sure. Homemade, maybe came in a kit form, don't know. But we can read there on the paper, 50 kilocycles, 2K, 200, 100 kilocycles, blah blah blah. What do we got? We know what that does. Not sure, 40 volts, 4 volts, okay. Amplitude maybe, I don't know. That just swivels around and does, well maybe that's volume. What's this? It's a switch, 3 position, ABCD band selector here. So yeah, don't know, and a 6 volt AC output. Okay, and of course for the probe, or yeah, whatever, we've got a TV aerial plug in there, socket. Okay, no, I just threw a couple out, never mind. If this thing works, I'll put a B and C in there. Power light obviously, and what's this? On off. Cool. There's a power plug, and I haven't seen one of those in, well, I can't remember when, but I have seen them. Anyway, hopefully we can get this thing going. Always handy to have another spare audio or even an RF generator. They never go astray. Let's get this thing out of the box and see what we're dealing with. Okay, got it out of the case, and let's have a look. Oh yeah, 4 valves. 6BQ5, cap can. What have we got here? 6X4, rectifier, and what have we got here? 6AG5, 2 of them. Okay. Alright, our cap can. What do we have? The cap can, the battery went flat in the camera. So we've got 250 microfarads at 350 volts each. Well, 247s will work for that. Anyway, nice case, nice aluminium. No, not anodised anywhere. Anodised? What is it? No. You know what I mean. Whatever aluminium doesn't rust. Shit. Okay. We've got caps everywhere. Yeah, okay, whatever. Another one in there. There. Hold on. Now I've got two. Got 2 in there. I know, a bit hard to see. There's that. And I've got this great big honking thing that's loose. Now come out. Okay. Well, that's a good way of putting it in. Already got 100 microfarad at 350 volts. Alright, so that's easy enough to replace as well with 247s. So, okay, I don't know if that's a choke or whatever it does. No idea. Let's just put that back in there for now. Okay, it doesn't want to go in there. Typical. Stay there. And, okay, switch. Ooh. I'm thinking, no, that switch there, next to the band selector, there's nothing connected to it. Oh, well, fair enough. Alright, so, power. Tell you what, just got to work out which one is the earth, if it is an earth, and there it is. And you can't see, but it's a little skinny one. Those 2 prongs there, they're nice and thick. So, while we've got it here, let's just check the transformer, pardon me, I'm trying to get the word for it, and see if we've got some resistance. 105 ohms. Okay, I guess that'll do. Alright, first thing, we need to get some power to it, so I'm going to get that socket out and wire up some temporary power lead for it. So I've got my power cord all hooked up, and might as well check the voltage coming out of the transformer onto the plates of the 6x4. So pins 1 and 6 are the plate. From memory, I think I'm right. And onto you. I think you can just see that. Yep. And let's give it some power. Yep. Plenty of power. Alright. And the globe, on-off globe, is lighting up. Looks to be a, I don't know, I think it's straight 240 volt. So, let's have a look at if it's producing any DC. I guess we'll use this this can here. So there and there, red on positive, black on negative, which I did test. That's just earth, the negative terminal. Alright, here we go. And the current limit is looking good. No obvious shorts. Looks like the rectifier valve's working good. Or working anyway. Don't know if it's working well, but just checking my voltage, 170 volts. Don't know. Well, let's turn that off. I mean, I don't know what that capacitor is doing, and the main cap is up there. It's going to be a bit difficult to get to. So, power's off. Let's check that valve. Expected it to be a little bit warmer than that. Tell you what, I'll put in another 6x4 if I get the same result, and then probably the valve's okay. So I'll just hunt one up. Right, got a new valve in there. Let's see what we get now. Unless the valve I put in's a dud. No, here we go. Not sure. Given the amount of capacitors in here. No, I'm at 200 volts, and I haven't even got 1 volt in there yet. Alright, I'm going to try and monitor the main cap. So I'll try and get some probes on there, or the clips on there, without shorting anything else out. Okay, managed to get the leads on. You can see there. I mean, yeah, you can't really, but we can. Well, we just try anyway. So let's see if we're going to get something decent out of it now. $180 volts on my end. Well, that's looking better. I can see a couple of valves light up. 107 volts, 108, 110, 11, 12, whatever. It's just going up and up and up slowly. Alright. Oh, pardon me. Think I've just looking at the voltage. I don't want to get zapped. Right, so that's off. I'm not sure, but I think that's a choke. There's only two wires out of it that I can see. Can't see what's on the other side of it, of course. But one is definitely, that wire there is going to the main cap. And unless it's just my poor vision, come on, just want to get a continuity reading, see if I'm right. Let me do this off camera, it's going to take me a bit. Well, I did the continuity checks, and yep, we've got from the cathode being fed to the choke, and then from there go straight to the the first capacitor filter cap, and then the DC is flowing through there, and it goes out this wire and it goes into the second filter cap. So I tried to get some resistance readings on it, and I'm not having much luck at all. I'll show you. So I'll just go straight to the cathode. It's easy just to sit on that, and I'll touch the other end, output of the choke. $100K and rising. Yeah, and then it disappears. And this is what was happening to me before. What's that? 35 meg? You're joking. Anyway, that would, well, if that's reading in the meg ohm range, the choke, well, no wonder we're not getting anything through the secondary cap and all the other caps as well. That would explain the low voltage that we're getting. So, and plus the cap can itself is pretty old, and there's actually some writing on that choke. What's it say? February 1946. Well, I don't think this was built in 1946. I'd say most likely 60s, maybe even 70s, given the type of capacitors in there. So I'm going to get that out, that choke out, and I'm assuming it's going to be like, you know, choke, normal choke, 500 ohm, thereabouts, and we'll put that in. I'll jumper it in, and we'll see what difference that makes with the voltage throughout the circuit. Right, got that choke out, and yeah, it's dead. So let's just, there's my replacement up the top, as you can see. Feed in, and of course feed out to the secondary. Alright, now hopefully this works well. This works. So too much stuff in there for me to worry about and get to the main can, but again, let's try with that big cap can here. Now, given that it's rated at 300 odd ohms, it should be getting some decent voltage out of it. Alright. Right, let's try it now. Let's see what we get. As the valve warms up. Still not a lot, is it? 1.3 volts. And jeez. No, I'm going to have to monitor that second cap. So I'll get my clips onto it somehow, and we'll come back and we'll run another test. I end up taking that cap can out, just loosened it up, and yeah, so I can get to the terminals because it was just impossible. So I've got the choke connected to its original wires, and let's see what we get. And pardon my arm again, I'll stand up and do it. Let's give it some decent voltage. I'll bring it up to 200. Yeah, okay. Maybe that's all it's going to give. Actually, that's not too bad. I mean, all I can compare it to is radios, of course. I'll actually just go up to 240. Just to make sure that there's definitely no shorts in there. Alright. Alright, so what I'll do, I'm just going to assume we're going to get this to work. I mean, look, if I end up scrapping it, I'll scrap it. But no, I don't think I'll do that. I'll change those capacitors there, get rid of that can, and put in some new ones, and we'll take it from there and just keep changing capacitors. I can't think of anything else to do. But before I even do that, I'll get that choke mounted up there properly. Okay, I've changed those, well, the main filter caps, which are right there, 247s in lieu of 50s, and that great big honking can that was just floating in the breeze, 100 microfarad, and there it is right there. So it's all hooked up, and we're ready to run some voltage tests on this thing. So let's get that in there. We'll just monitor that one first. Bring my multimeter up. Okay, let's turn on our power and get the voltage up. And hopefully, as I always say, I've wired it incorrectly. And is it going to kick in? Finally, yes. That's looking good. I'm at 180 volts on the Variac. Bring it up to 200. And that's good voltage. Alright, so two main caps, 225, 24, 25, nice and stable. I'll just turn that off while I go to the other can, or the other cap, and that one's just, that's earthed, but pretty sure, yep, it's earthed, yep, the negative side is anyway. So what do we got here on the positive? And we're showing 2 volts already, so power on. Well, that's a hell of a lot better than what it was. Cool. Alright, that begs the question, what is this? Is this RF or is this audio output? So that's what I don't know. Let's plug it in, or let's attach it to the oscilloscope and see if there's anything coming out. And yeah, I can't think of anything else to do. So alright, I'll get some cable and and we'll hook it up. Okay, I'm ready, and oscilloscope is running. I'll power this thing up again, and here's my oscilloscope probe. So black onto the chassis, and before I do that, I'm just curious as to, I think that's probably warmed up enough by now, what sort of voltage is coming out of there. It's 1 volt. What if I turn up the volume? Will it go up any higher? 1.5. Turn the volume down. Yeah. I'm assuming it's AC. Yeah. Don't know. Anyway, not a lot of voltage coming out of there, so let's attach. Here's my oscilloscope as it stands. Come back here, let's attach it to the output. Oh, look at this. So we've got a sine wave. Sit still. Up. There it is. That's nice. Let's play with the volume pot, which I assume to be the volume pot. Yep. Turning the volume down. Okay, calm down. Turn the volume up. I've got an audio generator. Okay. Cool. Switch that off. Back to the chassis. Let me just grab a speaker. And let's connect it up. So one end to the ground. Where's the other one? There. And do we get any sound? Yep. Not bad. It works. I got another audio generator. Cool. Alright, we'll turn that off. Oh, thank God that works. Like I said, I didn't want to scrap it, but my knowledge of signal generators is basically non-existent. I can change caps and resistors, but I really don't know how they work. But anyway, I'll proceed now. I'm relieved that the thing works, and I'm going to start changing those caps. So yeah, I'll do that, and I'll just come back at regular intervals, and yeah, cool. Okay, I've done 99% of the recapping, and I've tested it a couple of times while I was doing that. Still working. There's one cap that needs to be changed, and you can just see it there, right in there. Little red 16 microfarad cap, and that's feeding the output there. Or negative side feeds the output anyway. So I'll be changing that output to a BNC, and now at least I can move the volume pot out. That was a struggle, and I'll get that out and find a new place for the find some place for the new cap. Anyway, what else is happening? The faceplate's off. It's the only way to get that thing off anyway. And I've given it a paint, and that's all dry now. So anyway, I will persevere with that last cap and get that changed. Okay, it's done finally. So yeah, all the caps are in. A hell of a lot of wiring that I've had to do, given, you know, finding spots for all these bloody capacitors. And as I said, I've got 3 47s in there, a couple of 16s, a 100, 2 24s down there. What else have I done to it? Put a Nice Monday power plug on there. And I've given the faceplate a nice paint of gold. So that's good. Anyway, and a BNC plug. So let's see if the thing still works, because you know, the last 3 or 4 things I didn't bother checking. Seemed pretty straightforward to me anyway. So anyway, just get our speaker in. And there's a speaker down there. Right, power up. Power lights on. Cool. And let's just wait. See how long it takes. Taking a while. And there it works. Thank God for that. Cool. Alright, now give me 2 seconds and I'll get that back in the case and we'll wrap this video up. Guys, here it is, all done, back in the case, all finished, and yeah, I've painted pretty much everything I could, and look, it's come up alright actually. So let's give that final test, and on you go. And we'll play with this. And I mean, after all, it's just going to sit up on the shelf somewhere. And kick in. There you go. So yeah, voltage out, and that's maximum. Yep. And volume and bands, low frequency, high frequency, ooh, super high, and that's it. Well, the homemade kit of a audio generator is all finished, all fixed and resurrected from the dead, so that's great. It was a chore to do. It really was. Really tight in there. But kudos to the guy that put that together. I thought he did a really good job. So anyway, thank you all for watching. And one day I'll get a Dymo label and put some labels all over it and whatnot. But not today. I'm sick of looking at this thing. So I'll catch you all again very soon. Take care, everybody. Thank you for watching. Bye.